All right, guys, so this is the video for the live meeting on August 28th, and today we're talking about graphing and measuring, okay, because you're going to do a lab on Monday with all of this information. But first, just another reminder, your first test is on Wednesday. I'm going to have a small group study session today. If you missed the live, you probably missed this as well, but 9 to 9:30 on Friday and 12 to 12:30 or 12:30 to 1 on Friday, and those same two times on Tuesday. And then I'll post the WebEx links in that day's folder. All right. So for today's work, you're going to need your handout packet and two papers out of it. And I will show you what those look like just a second. So these will be assignment number 13 and assignment number 14, and assignment number 14 will have 2 pages in it. All right, so let's go ahead and get started. All right, so we're going to be needing this sheet that says graphing data on it, and we are going to be talking about the different types of graphs and measurements. So this should have graphing on one side and it should have measurements on the other side, and this will be your assignment number 13. All right, so there are lots of different types of graphs, but the ones that we see the most in our class are bar graphs, pie charts, and line graphs. And today you're going to be doing 2 of those. So you're going to be doing a bar graph and a line graph, okay? So something that you definitely need to know how to do is to do bar graphs and line graphs. And so I'm going to show you, first we're going to do bar graphs when we do practice, and then we're going to do line graphs. But both of them contain 2 sets of data. All right, so you're using those to compare the data. So no matter what type of graph it is, you're going to need some information on it. You're first going to need a graph title. So your graph title usually is representing what the entire graph is showing you. And then you're also going to have axis titles. So you'll have a title for your x-axis and a title for your y-axis. Now, on your x-axis typically is the independent variable. This is most specifically for line graphs. It might be a little bit different for bar graphs because it's a different way of comparing data. And then the dependent variable is on the y-axis. So when we put our axis titles on there, we're also going to put the numbers or however we're measuring. So if we're measuring in time, then we need to put the units for time. So we'll put the numbers so you can count up in seconds or minutes or days, whatever it is that you need. But we're also going to put that in the parentheses below. So if we're going to count in minutes and seconds, then we need to put minutes and seconds. If we're talking about the mass of something, then we need to put grams. If we're talking about a number of something like fish, then we'll put fish, okay? So you got to do that. And then you also have to make a key to be able to tell which group is which. So you can use a different shaped dot if you're doing a line graph. You can do different colors, different lines. If you're doing a bar graph, most often you'll use a different color for each bar to compare, okay? So those are very key components to your graph, and you will have questions on your test where you have to pick out the correct graph based on all the information that's given. You also have to be able to analyze a graph. So look at a graph and pull information off of it, which you did yesterday on your variables practice, okay? All right, next we're going to talk about measurements. And so we have several different types of measurements that we're going to take, especially in your lab on Monday. So first we have mass. All right, so mass is the amount of matter that something contains. So it doesn't matter where this object is, even if it's in outer space, we still have the same mass, okay? Now, our weight is based on gravity, and a lot of people confuse these two things. And actually, when y'all did your helicopter lab, a lot of you put, the weight of the helicopter was going to be the independent variable with our scenario, but it was the mass, because mass and weight are different things, all right? So when we take mass, we're going to use when we take the mass of an object, we're going to use a balance to take that mass. So we have two different types of balances. We have a electric mass. We have an electric balance. We also have a triple beam balance, and that's what you're going to be doing in your lab on Monday. And there is a video that shows you exactly how to use a triple beam balance. But when we do that, we're going to measure in grams. Okay, so that's your mass unit, is grams. And then our volume of a liquid is going to be in milliliters or liters. So you would use something like a graduated cylinder to measure the volume of a liquid. The volume of a solid or an irregular solid, so either like a box or even something like a little figurine, that is going to be in centimeters cubed or meters cubed or millimeters cubed. It's always going to be cubed because you're multiplying three things together. And then our last one is our length unit. And so when we measure in length, we're going to measure in millimeters or centimeters or meters. So in science, we don't measure in English units like we normally do with inches. We actually measure in metric units, which is why we use millimeters and centimeters and meters. Okay. So I'm going to show you how to calculate the volume by water displacement. And you will also do this in your lab on Monday. You will measure length on Monday. You will take the volume of liquid on Monday. You'll also do volume of a box by multiplication. So you're going to do all of these measurements on Monday as well, okay? But what this picture shows you is volume by water displacement. So what you're going to do is you're going to have a beaker or something with water, and you have something put into the water. So you have an initial volume of water. So in this case, our initial volume of water is 55 milliliters, and we're going to drop in a golf ball. And when we drop in that golf ball, it raises the volume of water. Now, we're not adding any water, but that golf ball itself has volume, and that's what we're going to try to find out because we don't know what the volume of that golf ball is. So we're going to try to find out the volume of that golf ball. So we put it in the water, and we look and see where the water comes to now. So our water has risen to 62 milliliters. So we're going to take our final volume, 62 milliliters, and we're going to subtract 55 milliliters from it, which gives us a total of 7 milliliters. But since we're finding the volume of a solid object, it can't be milliliters because milliliters is only the measurement for liquid. So we've got to convert that to a solid. All right. So in this case, we're very lucky that 1 milliliter is the equivalent to 1 centimeter cubed. So when we're finding the volume of a solid, we always do the unit cubed, right? So in this case, our 7 milliliters is then also going to equal 7 centimeters cubed. All right, so it's pretty easy. All you're doing is just subtracting the initial volume from the final volume and then making sure you have centimeters cubed. All right, so this is always how you do volume by water displacement, right? And you will again practice that on Monday. Okay, so these are also measurement tools that you will be using. So if I have a rectangular solid, then I will use a ruler and I will measure in centimeters or millimeters or meters, most likely centimeters. And I'm going to take the length times the width times the height, and I will get that in cubic centimeters. So I'll multiply those three things together and get something, 30 centimeters cubed or something like that, okay? To find the volume of a liquid, you use a graduated cylinder and you put the water in there and you see where that water comes to. And it kind of has a nice little dip in it just because of the stickiness of the water molecules. And then I have an irregular object by water displacement is what we just did. So you put whatever the object is in the water and then you subtract the different amounts, okay? So this is kind of like your cheat sheet for your volume. All right, now